Okay, and welcome everyone to the May 2022 edition of the Houston Java Users Group meeting. And a big thank you to Claudio Lassala for presenting this month. He's presenting his talk, Refactoring Test Code Beyond Red-Green Refactor. He'll talk about refactoring your JUnit code, or whatever the code that might be that you're using to drive your tests, because it's just as important to the maintainability of your code base as the production code. And also thank you to Improving. They have been a gracious sponsor. It's absolutely amazing. Feeding everyone who comes with pizza, and also providing hosting here today right now on Teams. And they're just an absolutely amazing company to work for. We're actively hiring Java developers. If you are a Java developer, please reach out to an improver if you know them. We have a fantastic recruiting team. They're very friendly. They're not aggressive. And they are just, it's just an amazing place to work, built based on trust, culture built on trust. I am the happiest I've been in a really long time. And working with just absolutely wonderful people that I'm excited to come and work with. Oh goodness, what else? Next month we have Frank Greco from New York. He'll be presenting virtually, but I was thinking that as many of us as we can, well, let's meet up in the office and watch it together and enjoy each other's company. But we'll also meet virtually too. And he'll be talking on JSR 381, the Java specification request 381. Although its initial the initial impetus behind it was vision, they've realized that it can also be used for machine learning. And so we'll learn all about it and the origins of it, I imagine, and then also how we can use it to apply machine learning algorithms to in Java, because we need those tools. Java is a big language. It's a great language, and we need to make sure that we can really do a great job and do machine learning service and help these machine learning algorithms run faster. So again, that'll probably be was it June 29th. So if you want to mark that in your calendar, June 29th is going to be the date. And I'm not sure it'll be Teams. Frank said he's had a little bit of trouble on Teams, but so it may be Zoom, or we'll figure it out as we go. But keep an eye out for the emails. Again, that'll be June 29th is the date, and should be a great learning opportunity for all of us. And what else? Again, thank you also to our door prize sponsors. If you want to type in that URL or that you see right there on your screen, or if you want to take a snapshot of that QR code with your cell phone, we have a lot of door prizes: IntelliJ license, Structure 101 license, Sonograph license. Venkat Subramaniam has given a 1-year subscription to his agilelearner.com website, and Webucator has also graciously donated a voucher for one of their online learning courses. That's all I can think of. Java 18 was released not too long ago. If you want to stay on the bleeding edge of things, definitely try it out. Yeah, I think that's about it. Oh yeah, also Garrett Grunwald is going to come in the fall and talk to us about Crack and the new technology that will help speed up the startup of virtual machines. So very exciting. So without further ado, Claudio, please take it away.
All right, will do. Thanks, Jim.
My pleasure.
Thanks everybody who joined in online, everybody who came into the office. Always a pleasure to see folks coming back, you know, and it's not just the Zoom thing, the thing. Right, the thing. There's real people out there, and it's always great to know. So I always put up my email there because, you know, I tend to always maybe overshare in the sense that I try to share as much content as I have, and sometimes it may not give attendees enough time to process through all of it. So if afterwards you come up with like, okay, now that I've reflected on the things that Claudio shared. Can I reach out with questions, concerns, whatever comes up? So that's my email. So make sure to grab a photo of that or screenshot or what have you. Reach out if you have questions or comments afterwards. I'm a technical director here with Improving in the Houston office. I've been writing code pretty much professionally since the mid-90s. I know, I don't look that old, but I am getting there. So I first started with, what was it, DBase 3 Plus, and then Clipper, and then FoxPro, and then Visual FoxPro, and then Visual Basic, and then .NET, and then Ruby. I've been like through all of these things, except for Java. Like, what the heck am I doing here? You blame on Jim, okay? But I've done a lot of C#, which is like a close cousin as far as I understand. And I'm originally from Brazil, and everybody thinks that I speak Spanish. So it's the same thing, right? Portuguese, Spanish, C#, Java, it sounds the same, it looks the same, but it's not the same. Okay, but you guys will see what I mean as I go through the talk here. I have many areas of interest, as you can see. Test-driven development or design, behavior-driven development, those are big areas of passion for me. Automated testing is a big area of passion for me. Clean code, patterns, doing things the right way. So doing the right things the right way, I'm big into that. And through the practice of writing clean code, writing clean tests, right? Knowing what tests to write, not just based on the system, but based on the people, the requirements, the behaviors. It goes beyond just the ones and zeros that we have on the computer. That's a big thing for me, and I'll be going over that. And the quote that I have on my business card there, what you do matters, but why you do it matters much more, is something that I really live by. I always take that step back to ask, why am I doing this again? Right? If I'm just doing busy work, why am I doing this? And if I cannot answer that question, I should just stop. And it's my approach as well for like writing code and all that. So as far as testing, where most of us dropped the ball. So I started writing automated tests back in 2003, 2004, when I first learned about writing what I thought at first was unit tests. Later, I've learned that I was really writing integration tests. I didn't know just the differences at the time. And I have a whole talk that I actually gave to the Java user group a few months ago. We have the video for that online, right, Jim?
Yes, you
for
do.
that talk?
It's on my
Okay,
YouTube
cool.
page, yeah.
Yeah, so I have another talk where I went from like, how did I get started writing automated tests and how did that evolve and how it made me not just a better developer, but a better IT person working with people trying to solve their problems, as opposed to, oh, I'm the guy who writes code. No, I'm not the guy who writes code. I'm the guy who tries to help, people solve real problems. As we get into testing, eventually we're gonna learn about TDD, test-driven developments or test-driven design, depending on the intents that you're putting behind the practice. So we learn about red-green refactor, right? Where red, we say write a test that is a failing test. Start with that. Make sure that the test will fail and it will fail for the right reason. We're not getting a false positive. Then we spend some time writing just enough code to make that test pass. And then we go ahead and we spend time refactoring code. Where a lot of us drop the ball is that we spend time refactoring the production code, the actual feature that we coded and deployed to the end users, but we don't refactor the test itself. And what ends up happening is that the tests end up getting so cluttered that people will just abandon them. It's like, well, nobody can read the test anymore. The code looks clean, the code for the feature looks clean, but the tests, nobody can follow what the tests are actually doing. And then there's a lot of like copy and paste related, because like the tests now have 300 lines of code. You need to create another test for a similar feature. You copy that, you paste it, you just change, whatever is different, and then it just keeps piling up. And eventually a new feature comes in, a new defects that you need to fix. Like, well, I cannot understand the tests, so I don't feel confident changing it. I'll just make the change to the implementation and roll with it. It defeats the purpose. And the amount of time, so the size of the boxes that I've put there is to reflect like how much time we usually spend in those 3 steps. Now, as I go through this, the programming language really does not matter. The approach that I'm going to be sharing with you guys here, regardless as to what language, what framework, what library, whether it's backend, whether it's for front ends, whether it's a functional end-to-end test, it does not matter. It's the attitude towards the mindset towards how do you write your tests, right? And then you just use the same approach across the board. With that said, most of the code here, you're going to see C#, JavaScript, TypeScript, but they're all curly languages, right? So you can translate it well into Java. There will be times, some of the techniques that I use that are very C# specific, because I know I'm using some C# features, and then I'm going to have to refer to Jim and say, hey, Jim, is there anything like that in Java? I just do not know right now.
Sure. Yeah.
Cool.
You're in good company. If I don't know, somebody else very well may.
Sweet. Awesome. All right. So because we understand the domain of pizza making, right? Everybody knows pizza. So this is like a very simple example, simple code that I use to demonstrate some of these ideas, right? So I have this method in some class called make meat lover pizza that returns a pizza, right? And the code, what it implements, it instantiates a pizza and it adds toppings to that pizza. Nothing fancy, right? Somebody says, hey, we need to create a test, write a unit test for that. Okay, that should be simple enough, right? And then day 1 of writing tests, we learn about arrange, act, assert, the AAA template for writing tests, right? Arrange, that's where you're gonna instantiate your classes, you're gonna set some properties, you're gonna prepare the environment before you act on the system under test, right? The thing that you want to test, some sort of behavior. And then you assert on what is the state of the world after you called into that method. We all learn that pattern, like day 1 pretty much. My beef has been that we learned that in day 1, and then 10 years later, we are still following that same approach. And it's something that I've been very adamant about. It's like, okay, yes, because we've learned that 10 years ago, it doesn't mean that we should keep doing it. The way I describe the AAA, the arrange, act, assert, it is a training wheels, right? You're getting started, you're learning. Always make sure that you have your arrange, your act, your assert. Otherwise, it's not a test. Well, Claudio, what could be missing there? I have seen code bases where they have the arrange, they have the act, but they don't have assertions, right? Oh, why would anybody do something like that? Well, because somebody has created a policy that you can only push code into the repository if you have 92% code coverage. Oh, how do we get code coverage? You have to execute through the lines of code. You write a test without an assertion. As long as the code does not throw an exception, you're good. You got code coverage, even though the tests are not asserting on anything, right? It's doing whatever and it's not blowing up when we do. But that does not really help, right? And the reason why I always make a big deal about that is because I always run into that scenario where I'm going through that. And then the problem is that the test, like the arrange and the act, usually go for like 200 lines of code. You get tired halfway through it. You don't get to the bottom. You don't see that it's missing assert statements, right? And it's just, for that sake, it does not help having tests. Another thing that comes out of this is the whole, like at the bottom of the test, you see a lot of repetition, right? Assert contains pizza toppings. Topping goes into topping.name equals cheese. And then the next one, it's the whole thing repeating over. The only thing that changes is on the far right. Problem is that the way our brains go, it's like, well, I'm recognizing the pattern. It looks like it's exactly the same thing, except when it isn't. I've run into situations where I spend a lot of time troubleshooting code and I fail to see like there's an exclamation mark that negates something. But the line is so dense in characters that I couldn't like see at first glance, right? So every time I see code like this, I want to refactor it because everything that repeats like crazy, I want to only see that once, right? And the things that I want to see is how is each line different from the previous, right? So problem with that approach is that whatever code, every single line of code that we write, it will get copied, period. Either by yourself, by somebody else, either tomorrow or a year from now. It will get copied, right? Somebody will have to create some sort of test similar to an existing one. What are they going to do? What are we going to do? We're going to find something that looks somewhat like what we need. We're going to copy, we're going to paste and make some changes. So that one test in one file that we had that looked like this, if we create like a Hawaiian pizza, for instance, guess what, right? Copy the one above, paste it below, change the method that we're calling, change the toppings that we are asserting on. And it keeps going like that. Not, it's how everybody learns how to write tests. It's how we all do, but eventually we should stop doing that. And that's my mission in this talk, is to get your minds going into, okay, if I see tests like this, that's a code smell, what can I do, right? And what approach should I take? Problems also with approach like this is that tests should not expose internal implementation or even implementation, because like in this case, we are seeing that, how do we check the toppings of a pizza? We are now seeing that the pizza has a toppings something. It's an array, it's a collection, it's a list, it doesn't matter, but it's something like that. And that thing has a property of type name. If we ever want to change that, how we are like exposing, if this is an array, now we want to change it to a list, well, it may change the way we consume that from the outside. The fact that now we have a strongly typed topping thing that has a name, well, what if we change that? What if name is no longer a string and it's a pizza topping rich type, complex type that you're using instead? Right? We are exposing too much of the implementation, even though the behavior shouldn't change, right? If we say, hey, meat lover pizza should have these toppings, if we change how we represent toppings, we shouldn't have to change the tests for that. Even though this is part of the public API of that object, we really shouldn't have to change the test that we're using to describe that. So those are some of the things that catches me there. What if those tests were written like this? Right? Instead of all those assertions, I had something that read like this. Assert pizza only contains the following toppings in a list of toppings. Right? It's still the same test. But at this point, there are no there's no copy and paste, right? There's no exposing how those toppings are actually represented, how they are implemented. It's just a list that states, hey, we expect the meat lover to have the following toppings. How we're going to implement that, I don't know, I don't care, right? Once we have something like that, that's a little bit of an improvement. And then as I moved, because the first slide here, the long word, to me, it looks like a German word. German is by far the hardest language I've ever tried to learn, right? Because it seems like one word, it looks like a sentence that's all meshed together. To me, it was so hard. What was that?
Mark Twain wrote an essay on that very fact.
Oh, I have to look
yes,
that up.
it's called The Awful German Language. If you ever come across, if you want to find it on the internet, it's not a very long essay, but it's pretty funny. It echoes your exact sentiment.
Thank you. I would totally look that up because learning many languages over the years, German is the one that really caused me trouble. It's like I cannot get my mind to work around that. And when I see a method named like that, I have that feeling. It's like, okay, that is a long method, and to find the word boundaries and all, even though you're using casing for the first letter and all, it's odd. It's like, why do we do that? Well, I'll tell you that at least in the C# space, that is the design guideline for methods in C#, right? It's like, oh, that's how we're going to name methods. Like, okay, I do see that. I love following the conventions, the guidelines, depending on the intent. The intent of this method here is not for somebody to be instantiating this class someplace else and calling this method, right? The intent here is for me to describe the specification of the thing that I'm testing. So at that point, you know, I really rather go with something I learned when I was doing some Ruby, you know, go with the snake case approach, where now it looks more like a sentence, right? It's still a method, right? It's still C#. Oh, but it looks like Ruby. Yes, I know. And I'm speaking English and it's coming out with a Brazilian Portuguese, a Brazilian accent, right? But the message comes across. Same thing here. Yes, I'm using C#, but I'm using it with the intent of explaining to the reader what is it that we're building here. Okay. Notice that the make meat lover pizza, I don't change it to that format because that's the implementation code of the feature that's going to go in production and all. But it's a different intent. Okay. All right, good. And then the other thing that you can see here is notice where I use casing, where I want to draw the reader's attention to. Assert pizza only contains the following toppings. Because on the previous, the original code, what if I get a pizza, meat lover pizza that comes with all that stuff and somebody puts in something else that is not expected? Well, this test is not going to fail. As long as the pizza has those toppings, all good. If it has more, the test is not going to catch that, right? So by changing that language right here, I'm drawing the people's attention to that. You should only have those. If you have anything more than that, I want to see information about it. Hey, your pizza got like, I don't know, nails on it. Whatever people threw on it. Yeah, that's horrible, right? So yeah, using casing with that intent. It violates all of the guidelines for pretty much all of these languages, but honestly, I do not care. Because again, it's an intent. What am I using the language here for, right? The wall of character there was gone. So usually what I do when I see those big assertions, I see what is it that they're verifying. I just push them into a separate method, somewhere that I can just call in my test suite, and I can reuse that because now I have meaning, right? That's the kind of stuff that I'm looking for. And then things that I'm using here is, yeah, I just passed the array parameter with strings of the name of the toppings, and I just do a for each on the thing, right? Just hide that away from the user's site. Yeah, that was the case I was saying. Oh, somebody threw, you know, pineapple on my meat lover pizza. That's crazy, right? That's horrible. So this, like, and then there are many ways to implement like the verification, because that for loop was just verifying the toppings that you actually have on the pizza. The other one I added is, hey, check for the count. Because if you have the proper toppings and the count is what is expected, then you're good, right? As we create different types of pizza, we don't have to figure out how to do the assertions. All we have to do is to call this little helper method, passing in the expected list of toppings, right? It facilitates reading existing tests and writing new ones, because part of it is already figured out, how to assert that the pizza has what's expected. With that said, so something like this, we would get this kind of error, right? Hey, we expected 6 toppings and we actually got 5. Usually that kind of assertion message is not really helpful, right? Because we cannot see, it's like, okay, what's the difference? What's the delta there? My next point, get to know your assertion library. Every single test framework, and I'm pretty sure that JUnit works the same way, you can tap, there's a number of assertions that you can use right out of the box, right? Assert that this thing is not null. That is, you know, it's a collection that contains at least one item. and so on and so forth. It's not true, or it's not no, it's null, it's true, it's false, is, you know, all the other variants of assertions. Get to know your library to see what's already there, and also learn how it actually works. Because for this library here, as I was inspecting, and this is a X unit in the .NET space, I can just grab like an array out of the things that I'm checking and just using assert equal. If I give it to arrays, it will give me the delta, right? It will tell me, hey, you expected the following array and you got this other one here, right? So the assert are equal not only works for numbers, you know, strings and so on, but also arrays. That might help you if your array is a short one. Because on this one, it didn't help me much, right? It's like, oh, I got everything I expected plus something, and I'm scared of what else is in that pizza, right? So for something like that, I would then learn how do I write my own assertion matchers. That's usually how these test framework calls those things. How do you create matchers so that you can say, hey, I have these two things. I want you to compare the two and tell me what's wrong about it, right?
So,
yeah.
Claudio, Scott has a question. So would the refactoring step be a good time to try mutation testing, or is that just another test process altogether?
I think that's a different process altogether, right? It's for mutation tests, it depends on the what does the test suite currently looks like? What does where are the skill set of the team there? Because if developers are following TDD, I'm hoping that, and usually like my approach is doing TDD, I come from actually BDD where I'm building code for the behaviors that we want to implement. And then I fall into TDD to design the APIs that will support the behavior that I'm chasing after. And then I'm coding, usually starting with the happy path for those behaviors, right? And then as we implement the happy path for the scenarios of the behavior that we are building, if we run into edge cases, okay, are those expected edge cases? Like, well, trying to withdraw money from an ATM and we don't have enough funds, for example. That would be one edge case. That's a very likely one to happen. Okay, now let's code for that. Great, we have good code coverage for that if we are doing TDD, because now we have tests that cover the code that was written. Now, if there are permutations or things that we cannot really anticipate how people are going to be feeding data into it, then I would resort to like libraries that would help me like create all the kind of fuzzy data that's going to get sent into something, right? Sometimes as part of the, like in this case, if the creation of a pizza is always the same, in the case that we have some input and then the output is going to be a pizza that has toppings on it, yes, I could create one test and then use, I don't know in JUnit what the equivalent would be, like row test attributes or something like that, where you can like decorate the test with a list of like rows that have the different parameters that you want to send into the test so that you write.
In JUnit 5, you can pass in test data in your test now.
Sounds,
yeah.
Yes, right. So if you do have like a subset of data that you know you want to exercise things with, I would do that. But if you actually do need permutation tests, like just load as much data as you can and push through that pipe and see what comes out on the other side, I would write a different suite of tests just for that. Because I don't see, I haven't run into situations where I want permutation tests for everything I write for the software.
Yeah, so we're talking about mutation tests, not permutation tests, but mutation tests that will fiddle with the operations of the production code, basically. So plus becomes a minus, minus becomes a plus. Yeah, so what they do typically is they will, it's not just code coverage, but it makes sure that your tests are sufficiently executing all corner cases of your production code.
Okay.
So that, yeah, for example, methods that return a void will throw an exception, or methods that throw a that return a value will return a void instead. There are other various operations. The most popular engine is PyTest, P-I-T-E-S-T, but there are others as well, and they're pretty quick to run for the most part, because they only execute the tests that are relevant for that particular mutation. Doesn't run all the tests in your suite. So it does take a little bit longer than just a regular JUnit suite, but it can uncover a lot of areas that do need additional testing to be considered.
Gotcha. Thank you. Good stuff. So yeah, I guess going back to the original question, like when I'm refactoring tests like this, I'm mostly looking for ways to make it easier to understand, right? That's, you know, trying to take baby steps to just improve it a little bit so that we improve the quality of our test code, and then we expand it from there. Good deal. So can we make this better, right? That's so a test that would look like this is already, you know, better as far as I can tell from the original one. Can we make it better? Absolutely. So the ugly looking comments, all of my IDEs, I always format comments so that it shows like that, you know, yellow on red. I'm not a big fan of comments in code. If comments are there, if somebody took the time to write comments, I need to read it. Somebody took the time to put some comment in, so I better read it. If I read it and the comment does not tell me anything that I don't already know just by reading the code, I'll delete the comment. So the arrange act assert thing, that is not adding anything for my understanding, because every test follows that pattern. It's just, to me, it's a given, and that word will come back. So I want to get rid of those ugly comments that really don't help me understand the code. So I've been a big advocate of going from arrange act assert AAA to given when then GWT. So arrange becomes given, act becomes when, assert becomes then. Claudio, that's just words, right? Like, yes, they do matter. Because as you see later, when I'm fully refactored with this, we're not going to see things like, you know, assert, which in this case is more of a technical thing, right? If I have then, it's more of like an English for everybody type of vocabulary. And you'll see where we're going to land with that and why I make a big deal about that. Right, so I want to change that structure so that it conveys a given when then template. So starting here, as we see the redundant code there in both of these tests, of course, in real world, we end up having like dozens or more tests that look very much the same, and the arrange is for the most part exactly the same. In this case, it's a very simple class. It's just one class that we're instantiating. In the real world, it's one class that has a bunch of dependencies that we're sending in. Usually we're setting up mocks and stubs and spies and putting all that together, and then instantiating a class where we send all that stuff in. So we have like 10 lines, 20 lines of code just with setup that gets copied, right? So when we have an arrange like that, which becomes a given, I want to extract that into a separate method that I can reuse. So in this case, what's redundant is the instantiation of the pizza maker class. Why do I want to abstract that away? Well, what if we decide to create an overload on this constructor, or maybe change this constructor to take one parameter? Well, now not only do I have to change it here, but also here and in every other test that instantiates that class. So I want to hide that away so that it only happens in one spot. So the way I've been doing that, I extract that into a separate method, which I name it given. What is it? Given, in this case, a pizza maker. Okay, put that in a separate method. Once I have that in a separate method, I'll run my tests, make sure that I didn't break anything in the process, because sometimes it does happen, right? And now that I have that here, I can go down to my second method. When I start typing given, I see all of my givens that are available in that class. So from that point on, for me to write new tests, I just write a new method and I say given what? Well, I have a list of what I can choose from. Oh, this one, great, right? There's less cognitive load for me to write new tests because it's already right there at my fingertip. I don't have to think much about how do I instantiate the pizza maker. Does it have any dependencies? Just say given whatever. If you do want to see what are the dependencies of this class, go to the definition of that method and you're going to see how it is all set up, right? So the implementation of instantiating or getting an instance, a valid instance of a pizza maker is hidden away someplace that we can get to. Oftentimes folks will ask me, hey, Claudio, but then when you're putting the instance of that class into a field, that means that you're not going to be, you may run into concurrency issues, right? Because if you run those tests, like in this case, we have two tests, if they run concurrently, they're going to be accessing the same variable, the same field. Wouldn't that be a problem? Yes, but
maybe in .NET.
Okay.
In Java with JUnit, each test is instantiated in its own instance of the class. If I recall correctly. So like each test is effectively isolated.
So every test method inside of the class, so so like in this case, it would have two instances of the test class.
I think so, yeah.
Really, that's interesting.
Yeah.
Okay, good. So that's good. I'm not sure because I remember back, at least in other versions, like in unit, I think that would be a problem because the test class would share that instance with all the tests within the same.
Yeah, and if you had a static variable, then yeah, that would be an issue, but not instance variables.
Yeah, if it does indeed have one test class instance per test method, then that wouldn't be a problem. So what's my thing has been though is that I set up my test framework, my test runner, to not run tests inside of the same class in parallel, inside of the same file in parallel. I want them to run, one at a time. It's like, well, but what if the test class has like 100 tests? No, my test classes are not going to have 100 tests because I keep them very small. And usually within each test fixture, that's how we refer to those classes, I have like 2 or 3 because I really break them down to the context that I'm testing. So instead of having one test fixture per class that I'm testing, I have multiple test fixtures per context that I'm using that main class. Flips things around there, right? But that's I have a whole different talk just about context-based testing, which pushes this notion a little bit forward. All right, so same thing with the when part, right? So when making pizza lover, I will extract that into a separate method. Like in this case, when making pizza lover pizza will be the name of that method, right? Use casing to improve readability. So here, when making big letters, meat lover pizza, right? Because all the tests here are about making pizza. As I'm skimming over that text, the big letters, they will scream at me. And my brain will say, oh, I'm fine just reading meat lover. I get the context, what it is. I don't have to read every single character of that sentence. Those GWT, the given when then methods, I usually push them to the bottom of the class. I do not want to see them as I walk into a test file. When I walk into a test file, I want to see given when then, right? Is this good enough? One could say, yeah, that's already pretty good. Well, not enough. This is more like it, right? So I turn everything around so that when I arrive at a test file, this is what I read. Hey, meat lover, what about meat lover? Well, given a pizza maker, when meat lover pizza is made, then only the following toppings are expected. Bam. It is still the same test file. Those given when then methods are at the bottom of the file. So all the detail as to how those things come together are right there. If you just keep scrolling, it's going to be there. But at the top of the file, this is the first thing that I see. Why do I raise a big stink about it? Well, something like this, I can share with anybody who can read English, not just technical people. The initial one, I can only show to technical people who know the language that I'm, using, who knows about like setting up mocks and stubs and all that stuff. Right here, no, I can use this as a conversation point with everybody on the team. And that's highly appreciated, right? So that's where I want to land with my tests. So now here, the business is growing. So now we want to make a Brazilian pizza, right? And since this is my restaurant, I want to have my Brazilian pizza be one that has a lot of meat and cheese, right? That's my Brazilian pizza. So how do we support that? This is how we go from behavior-driven development to test-driven design. The behavior that I'm describing is this one. Given a pizza maker, which we already have a method to say, given pizza maker, when a Brazilian pizza is made, well, we don't have that. That's a new thing. It's a new requirement. Okay, I'll just spell it out like that. Then only the following, well, we have a method that we can call for that, right? Then only the following toppings are expected, a list of those toppings. So this is me applying behavior-driven development. I'm thinking of the behavior first, not how it's going to be implemented, right? From there, when I start like implementing that when Brazilian pizza made method, that's where I'm doing TDD. That's where I'm designing the API that I want to have to enable the behavior that I described at the top, right? So in this case, I'm saying, I have a pizza maker right now. It doesn't have a method for that. Should I create a new method named make Brazilian pizza? Oh, and by the way, the guy is calling for a lot of meats. So are we going to send that in as like a special request? I don't know yet. I'm thinking those out loud. This is me designing the implementation. As I'm designing this, I may start with that. I may see my test pass, right? If later I decide, you know what? The Brazilian is really picky. We're going to have to bring on a different type of pizza maker, like the premium pizza maker. It's going to be a different class. Well, now what? Okay, your test, the one that describes the specification will not have to change. Only the implementation, the API into whatever it is that you are building. So remember, that's like the way to define refactoring. We're changing the internal implementation without changing the external observable behavior, right? BDD, I'm seeing the external desired behavior. TDD here, I'm describing what is the API that's going to grant me that behavior. Inside of that API, whether it's using arrays, lists, objects, functions, it doesn't matter, right? It shouldn't surface here. All good? Excellent. All right. Now we're talking with people, right? As I said, if you open a test suite where the test fixtures look like this, only developers will be able to read it. And many developers will not even want to read it, because once it gets to like 1,000 lines of code plus, we just give up the practice of writing tests. Okay. When you turn that around to something like this, well, now anybody who reads English can follow along and see what's going on. Still the same test file. We just reshaped it in a way that's going to make more sense for people to read. And then you can have, intelligent conversations with people about the behavior, not the implementation, the behavior of what we're trying to build. Okay. And look, Mom, no libraries. right? I'm not using anything special for that. This is just plain old C# in this case. In Java, Java would be the same thing. In JavaScript, TypeScript, it's the same thing, right? I'm just using the test framework and the test runner that will execute whatever was created with that framework. That's it. Why do I raise that as a thing? Many times when people are asking me, hey, Claudio, how do I get into BDD, behavior-driven development? Because we're starting to like set up our CI/CD pipeline and we're looking at tools and this and then I'm like, it's not about tools, right? I pick up a piece of napkin and a pen and I start writing given, when, then. Here, this is BDD. If you can do this on a piece of paper, any tool will do. If you're picking and choosing a tool that will not let you do this, that's the wrong tool, right? So that's how we get started, putting our minds towards that goal. Business will thank you, right? Because again, if you show to the business, hey, the thing that I've been busy with the last sprint or so, it looks like this, they're like, yeah, that's all Greek to me, I don't understand. If you show them this, it's like, oh, that looks like my business. Oh, you're building exactly what I asked you to build. Or, oh, wait a minute. No, that does not sound right. Who's making the Hawaiian pizzas here? That's not how we do Hawaiian pizzas here. You open up for this kind of communication, right? So there is transparency into your work and the expectation setting, right? Because the thing that you are building is based off of the expectations that the business at one time or another gave you. And then if the people writing the requirements wrote them in the shape of given, when, then, like that, beautiful. They will see, oh, that guy is listening and they're following what we're telling them. In many cases, I've worked in, most cases I work in projects where the people writing the requirements, they don't think in those manners. So as a developer writing my test first, I have to write it out like that. So when I'm writing it out like that, instead of implementing the feature first, I'll write the tests like what you see on the right here. I'll write just those specs. Before I do anything else, I will share that with the product owner, with the business analyst. And I'll say, hey, here, does that make sense? Am I on the right track? If they say yes, good. If they say, no, hold on, no, those are the wrong assumptions. Oh, okay, let's flush that out before I spend any time creating databases and tables and setting up security and bringing this library and that library and blah, blah. No, I spend time here. Cheaper that way. Business like that. It's like, oh, that's cheaper. Yeah. And you're delivering the thing that we actually asked you to deliver. Beautiful. Do more of that thing. Right? Good deal. All right. Sorry.
So a quick question from Dan.
Yeah,
So what are your thoughts on passing in parameters to the when clause? I like to be able to have multiple tests with the method referenced in the when clause to be consistent and only the parameters are updated.
I do use that as long as I can. I can make it readable. So sometimes, let's say that I don't want to have the, I don't know if you guys noticed, but whoops. Like here, notice that this first iteration here, right? Even though we can still read this fine, we would see this underscore pizza and new square brackets. You know, it's like, what the heck is that, right? There's more syntax needed to indicate, hey, we're passing in an array of strings. The final implementation, notice that I'm using the params string, so I can send it this way. So I hide the fact that, oh yeah, that's an array of something. So for the people reading this, they don't have to like parse through like weird language symbols. So yes, I do leverage like when it makes sense to pass parameters into my when, but only if I can still make it readable. If I can't, I rather create multiple different when methods and make it as descriptive as possible for people reading it, being able to understand it.
Claudio, thanks.
You bet.
What I typically will do is I'll do a given. The given represents the parameter, so you know what its context, and then that's also what's passed in, so you can kind of follow it that way as well.
Gotcha.
That's just the trick that I usually use.
Sure. Yeah, I try to find this balance, right, where I can write new tests in the easiest manner possible while still keeping it readable so that I can collaborate with people who don't necessarily understand the programming language. And then I'm trying to find that balance. If I have a situation where I know that only developers are going to be reading those tests, then I'm a little bit more relaxed as far as, you know, how much syntax am I going to be seeing in the test. So I just I program to my audience, right? Cool. Any other questions there?
When you're starting out, a newbie would write a Java class, a test that contains the test, and a Java class that contains the implementation. You've hinted that these tests can get out of hand, so you break those down into separate classes for a context-oriented feature set. Or something
yes.
Like that. Organizationally, just trying to keep track of all these files. What is your recommendation in terms of naming? You always have the word test first or class name, or at the suffix at the end?
So how does it work in Java? Do tests reside with the implementation, or are they located in a separate project altogether?
So they typically, from what I have seen, they are in the same project as the classes they test.
Okay.
They are in a separate part of the source code layout, but they are also, however, they are also typically in the same package. So they're namespace to the same class that they're testing. But in, like, you have source main Java and source test Java.
Gotcha.
Yeah. So, but those are the source roots that those packages live in, and those packages are identical for the production code and the test code and the test class that is testing the production code. And so the test classes have access to the package. They can access, say, package local classes as well as public classes.
Gotcha. Okay, thank you. Yeah, I asked because in like JavaScript, TypeScript, it's kind of similar where the tests stay together with the implementations, right? In .NET, we tend historically to separate those. But what I do is, like in a case like this, I would create, say, a specs file, as in specifications, and that's where the test or the spec files live. And I name those after the feature, not after the class, right? Because here's the thing.
Classes are an implementation. That could change.
That's exactly right. So instead of naming my specs based on the classes, I name them based on the features. Because if I want to change how they're implemented, I don't have to change my tests. They're describing the behavior, not implementation.
Yeah, so you're getting into more like you're moving a lot more towards Cucumber style BDD, where you have feature files and then you have your test harness, where you have your feature files are run by your behaviors, and basically implemented by the behavior code. That I forget exactly what they're called offhand.
Steps, so the behaviors and the steps.
Yeah, the steps. Yes, so your steps. Yeah.
So I have I worked with Cucumber, and a lot of the stuff that I've learned about BDD came from Cucumber. So a lot of this style comes from that, yes. And I think the main lesson that I've learned was, regardless as to whether I'm writing like Cucumber style of tests, end-to-end style of tests, I follow this approach all the way through, from the outside in. If I'm describing a user workflow, I do it this way. If I'm you know, down close to the metal, maybe writing a JSON parser, my specs will also look the same way. I'm going to describe the parsing behavior, not the parser. Right? Because then if I want to change my implementation to the parser, I already have the tests, right? The descriptions of the behavior that I want out of the thing, whatever it is that I'm building, whether it's a very business oriented thing or whether it's a very technical thing. Even if it's a very technical thing, I still have to use English to describe what is the behavior, what is the feature that I'm building here for this technical thing, right? And I focus on that.
I heard a talk by Devlin years ago, Tech Fest, of picking Monopoly game and using that as a guide to help discover Java classes and so forth. And so I got inspired to do the same thing in JavaScript, but I had it all in one file because it's just so much simpler to do that. But I developed the habit of writing the test first and then the code.
Yeah.
And the thing I learned, because to me, and probably most people think this is so stupid. Why do you write code that will fail? And I like you said something at the very beginning of the talk, fail for the right reason.
Yes.
And the right reason is you haven't implemented any code, but the name of the function and the name of the function that you're calling in your test, those match. Because if that fails, you know, compiler error or runtime error, then
right.
You're behind the 8 ball already.
Exactly.
So the light bulb went off and it makes sense to me to do that.
Yeah, because if you write a test, you run it, it passes. Like, wait a minute, I wrote the test first, I didn't implement anything. How come it's already passing? It's like, am I magic? You know, a magician? So that's the point. Absolutely. All right, excellent. Well, let's keep moving here. I like how we are already going towards the context-based stuff, but that's, as I said, it's a whole different talk that I have just to practice that. So we talked about this bit. Yeah, we covered that. Good. So where's the love for Java, JavaScript, you know, TypeScript? It's similar. As I said, when I look at code, regardless of what language, I look for these patterns. So like this, what we're seeing here, this is TypeScript, but it could very well just be JavaScript. But look at the repetition, right? I'm reading a lot of expect result has own property, some property to be false, to be false, to be false, to be false, to be false. Oh, this one's to be true. Wait, why is that one supposed to be true, right? Oh, and this one, I see a little bit of a break here. How is it different? Not sure. Oh, here. Oh, okay, here. All of these we're expecting the result. This one, it's result sales order header, right? So it tricks our brain because like it looks almost like the same. What's different? You have to go like, right? It's just too much work, right? So instead, when I see code like this, like, okay, how could I make it better? And then I've learned that, well, maybe I can say expect results to have properties, all these properties. Expect result to lack properties or to not have the following properties, because this is what these guys are really looking for. Does the object have the following properties? Does it miss or lacks the following properties? And then this other one, the sales order header, does it have these properties? Right? That's what these things we're trying to do. So here what we did was, okay, let's make sure that we have language to explain what is it that we're looking for, right? And here's the part that I've mentioned. Well, where does this to have properties method or function comes from? Well, it didn't exist. We created, we enhanced the test framework to account for that matcher, right? That assertion matcher, or however different languages we use that. The thing being that as you start iterating over your tests, start looking for opportunities to create your own assertion libraries that are your own DSL, domain-specific language, where you're going to create assertions that have everything to do with your business. If your business is pizza, I'm expecting to see methods that will say the pizza has the following toppings. Because the people who created the assertion libraries, they know about booleans, they know about dates, they know about strings. That's it. They don't know about anything else from the real life. you do from the business that you're serving. So create assertion libraries for you to verify your own business, right? It's a domain specific language for assertions. When we create those assertions, those more specialized assertions, then the errors that we produce, should those tests fail, we can control the language, right? The wording that we use there. So in this case, that one extension that we created, we said, hey, object is missing the expected properties. We received the following properties, and there is a property missing. This seller ID XXX is missing, right? So this is not how the test framework gives us the error. We wrote that because that's something that made sense within this context where this code was written. As soon as the developer sees that, it's like, oh, I know exactly what it is, right? So make sure that's not like a, oh, expected true and got false. Well, what does true even represent? Well, we expected the pizza to have, sausage, and it doesn't. Instead of true or false, give it more meaning to help people figure out and troubleshoot the problems. Remember extending the assertion library? So this is, we're using jest for the TypeScript stuff. So this is how we extend jest, right? We say, hey, expect, we want to extend the expect thing in jest to have properties, the method that we created or the function that we created. And then we have the implementation where, hey, we get two arrays and we're comparing the two arrays and we are reporting back. Hey, object is missing, what have we received? What's missing, and send it back, right? Usually the ways to implement these measures is pretty simple in all languages because it's a Boolean verification, right? And then you have what you got and what was expected, just report back, right? So make sure to take some time to learn how to do that in your test framework of choice. This is a test for an Angular component. Remember, I said I don't care if I'm writing like Cucumber type of tests that are very high level, closer to the user, or whether it's something technical. Even our tests for Angular components, they are very granular, very business or technical oriented. Look at how it reads, given when then, right? Depending on the context, like in this case, we have it's a more technical thing. We see something like, oh, have properties at the root level. Well, yeah, to the business that may not make a lot of sense, but to the developers, oh yeah, I get what that says, right? Even though at the top we see sales order draft, initialization to sales order. So we build some of the business specific language into the tests as well. And here's something for Cypress. So we are using Cypress IO for the end-to-end, the workflow functional tests. So in writing some Cypress tests, I've run into this kind of language. CY for Cypress, we want to get the following elements on our screen, should, and then we receive a div that we have to send into a function. And then there we want to say expect the div text to include blah, blah, blah. It's like it's a lot of syntax to remember. Every time I want to essentially say, hey, that div somewhere in the page has this text. Every time I had to look up this and copy and paste. I couldn't remember exactly what would go where, right? I said, okay, what is a better way to write that? And then we arrive at this. CY, so Cypress gets the following element, should have included this text, right? So it's easier to learn this than it is to learn this, and we can reuse. Well, have dot included text, what is that? It's us tapping into the assertion library that we are using with the Cypress stuff here. In this case, it uses this chai thing. And says, hey, assertions, I want to add a method. This is the name of my method. So this is where we could tap and create like a domain specific language. You could say pizza includes toppings, blah. Bank account has, deposits, blah. Whatever the language of your business is, here, right? Build something like that write the assertion, the logic that verifies two values, and report back in a way that actually makes sense to the developers working with that code base. They make a change that causes a test to fail. They see a test error that will tell you something more meaningful than we expected a true, but we got a false. What does that mean, right? So stuff like that, get to know your assertion libraries. Here's some more Cypress IO tests. Look at the functions are named when I blah, blah, blah. Then I see blah, blah, blah. Inside of those methods, if I see too much syntax, I find ways to clean those up. So we went from the thing on the left to the thing on the right, where we say, hey, we want to visit category 1. We get back the category ID, right? Verify category is meat and delicious meat. We want to keep the ID that we just received for further processing down. And we also want to verify that the add API called with the following parameters, right? So verify add API called with the following parameters. It's easier to do this because this is just a JSON that we're expecting to go in, as opposed to remembering, oh yeah, we have to do CY get add its request body should deep equal this other thing. So all of that syntax that every time I have to look up because I cannot remember it, how can I abstract that out in some place that I can just reuse and not have to worry about the implementation details? And doing it like this, go ahead.
I see. You could basically say that you end up missing the forest for the trees. You end up,
Yes.
you're focusing too much on the details, and you're not seeing the bigger picture. You're not able to paint the bigger picture. And
Yep.
that's it's throughout. That's what you've been saying all along. But that's a different way to look at it, perhaps.
Yeah, and doing something like this, like, oh yeah, this is how in Cypress we verify that the application has made a certain call into an API. Well, the good thing that we hid that away is that a new version of Cypress, was dropped where they changed the way that that kind of verification happens. Well, if we didn't have that, we would have to go and fix like hundreds of tests. Since we had something like this, we go change it in one spot, right? So every time we are using somebody else's code, think about it. It's like, should I put my own abstraction in front of that, right? It's usually a good idea anyways, because it documents your assumption as to how somebody else's code is supposed to work, right? If they change the way that their stuff works, your assumption of that does not change. You can either adapt your code to their new version or replace their version with something else, but you don't change your assumptions of how things are implemented. Okay, so it's just always something to, when you're using somebody else's code, always put some thought into, should I hide that stuff behind my own abstraction? Right? Everybody, right? Everybody. Good. And by the way, that's still a Cypress test, right? Because the things that we are looking are the things that I said, I push it to the bottom of the file. The thing that we see when we open that file, look at that. It's like, it hardly looks like a programming language, except for like the curlies and square brackets at the top and the bottom and the underscores, right? But it reads like English, right? We are describing a feature, catalog, item categories, we're adding categories. Given I have permission to add categories, when I visit the categories list, then I'm able to see the item categories. When I indicate I want to add a top level category, then I'm able to enter category name and code, right? So it's describing it straight out of the requirements that we got from our user stories or from the conversation. Sometimes we don't get requirements like that, but through conversations that the team has with the stakeholders, we end up writing out this and say, okay, does this reflect the conversation we were just having, right? Write this. Once you get, yeah, that's what we want to go with, then we can implement the feature, the test, and all that stuff.
So I know that you have given and then when then. I know that Bob Martin has advised against doing arrange act assert. But that kind of looks like what you're doing here. or could be doing here?
So probably I don't remember where Uncle Bob had that, but that's probably when we're writing unit tests. It's a different kind of test.
Ah,
So,
okay,
yes.
fair point, fair point.
Yes, so absolutely. So right, what Jim is saying, oh, but here I have given, when, then, when, then, when, then. So, well, wait a minute. For unit tests, like if we're testing components, we're testing like some more technical stuff, given, when, then, that's it, right? You may have given this and to compose your context. You have one when, and then you may have multiple things that you observe out of that one when. That's the way to go. This we are doing when, then, because here the unit is a workflow. That's the unit that we are testing. So the user is going to do this, and then the app will react like this. The user is going to do this other thing, That whole thing is a unit, right? So if the unit is like, it's a unit of work from the user's perspective, the business activity perspective. It's like going on the Amazon website, making a search for a book, clicking that book, putting it in the shopping cart, selecting, hey, I want to pay it by credit card, ship it to this address. That's the unit. So that's when we're going to see given, when, then, that's the unit that we're testing. Cool?
Yes, thank you.
Absolutely. Yeah, thanks for pointing that out. That's an important distinction there.
Question. Does
Yes.
Jim work in
Yes.
Jim Betancourt at
.com. Yeah.
Okay.
Yeah, so Jim.Betancourt. There you go.
Hey, Jim, this is Doug Smith. Hi.
Hey, Doug.
Yeah. Good deal. All right. Let's see. Same language, English, better communication, right? So here, what we see, 3 examples of 3 different tests in 3, let's see, 2 different languages, 3 different test frameworks for front end, for back end. The syntax changes slightly because we go from C# on the left to TypeScript, but the actual spec, it looks like one language. It looks like English, right? On the left, it could be a unit test, it could be an integration test, it doesn't matter. We write it like this, given, when, then, right? A unit or integration test for the front end, like how we write, this is an Angular project, so the front end is written in Angular. So the test for Angular, they also have given, when, thens. The thing on the right is the end-to-end test, the acceptance, the functional test for Cypress, also given, when, then. Right, so that's something that I've learned a long time ago, and whether I'm in, C#, .NET or not, Ruby on Rails, this is my approach. So whenever I need to learn a new programming language, a new tech stack, what I've learned is the first thing I want to learn is how do I write tests in that tech stack? That's the first thing I want to learn. And then the next thing is how can I make my tests look like this? Right? And then from there, okay, that gives me the room to learn, okay, what is the idiomatic way to, write this code in this language? It happened to me when I first went into Ruby that I was writing Ruby with a C# accent, right? So the code compiled, it ran, it passed the tests, but I was writing it with a C#, mindset. Well, since I learned how to write the tests first, which is a small subset of what I need to learn, then I could get my feet wet in a language with my background. And then with the test passing, I could go talk to a friend who was, a Ruby specialist and say, okay, what's the Ruby way of writing this code? Right? Much more effective way to ramp up into the solution there. As I give this test, talk, a lot of people ask me, okay, if you're doing that way, why don't you just use Cucumber? Well, like I said, if I'm writing tests for some very technical things, I'm probably not going to write Cucumber tests for like a JSON parser that I'm writing. Okay. With that said, if I have, for me, it depends on who's writing the specs for the system, who's reading, who's maintaining it. Because if only developers are writing and maintaining those things, I don't want to deal with a Cucumber. It's too much, right? Writing the thing in plain text and then creating the steps in the language of choice and it's too much work, right? With little value. If I do have, say, business analysts writing the English part, beautiful. I'm going to do Cucumber all day from the outside in for the functional test. Absolutely. Right. So I always gauge that. Also, there's the other thing where if there's certain people writing those specs, you know, to get us started, we implement the feature and people will never ever go read those things again, then I wonder, okay, maybe if there's somebody like a business person writing those in plain English like that, but that person's not going to actually maintain that in the code base, what I'm going to do is find a way to copy this, paste it in my spec files, and then take it from there. Because if I'm going to be the one maintaining that stuff moving forward, I want to be closer to the tools that I use on a daily basis to maintain that stuff. Okay, so what tools to use depends on the maturity of the team, who's writing, who's reading, who's maintaining that stuff afterwards. So based on all those variants, then I make a decision as to what tool to use. The language, the approach, that I don't change. What did we learn? Refactor tests make refactoring implementation code easier, right? If you have your test describe the behavior, the feature, not the actual implementation. That's another point as to, you know, when people ask, oh, so I'm pretty sure I'm doing TDD. Okay, tell me about your process. Well, I write the implementation code and then I write the test immediately after. Isn't that TDD? No, that is not. Because when we do something like that, we are writing the tests based on the implementation, right? We're going to see, oh, these are the classes that I created. These are the dependencies that I'm going to have to mock. I'm going to write tests for that. So your tests are driven by the implementation. When you write your tests first, you are driving the implementation based off of your tests. That's what test-driven design is. And it makes a big difference.
You won't write unnecessary code.
Exactly. And you're not going to get stuck in the, oh, I'm creating this one class that's going to do everything. It's like, whether you're going to end up with one class or an aggregate of classes, it doesn't matter as long as they give you the behavior that you're looking for, right? So many times going with this approach, what happens is I do TDD, I write my test based on the behavior, I get it going, I get validation, all good. I then do my code review and I say, you know what? I have this one class here, but right now I believe it's violating the single responsibility principle. It's doing a little bit too much. I want to split that into separate classes. Okay, I can go ahead and do that because my tests go against the feature, not the one class that I created. Okay. Good deal. So red, green, refactor, make refactor a big thing and make sure that you're refactoring your tests and the implementation code. Usually I refactor the test first to make sure that the tests reflect the feature, right? And then I'll refactor the actual implementation code. Okay. All right. Questions, comments, concerns?
So
Is that a framework, a style, both?
Cucumber is a framework, it's a test framework and test runner, okay, which allows you to write the features in plain text, okay, right? They look somewhat like that, yeah, right? It just, you follow that format so that people who are not technical necessarily can just write these text files.
Kind of a way of creating structured pseudocode in a way.
Please don't look at it like pseudocode. Okay. Because what happens is people start like writing the specs and they start talking about technical concerns. Like when I click on the placeholder button, it's like, there's no button. No, there's no button. As a user, you're not thinking, oh, I want to click on the place order button. No, we think I want to place an order. So the language here should say, when I place the order, right? So it has to be like, forget computers. It's how real people actually think and interact on a daily basis.
You're writing a procedures bang up for the next person.
Right? So we write it that way, and then, well, how does that become executable? Well, the Cucumber framework will allow, it will see each one of those steps, the given, the when, the then, as a distinct step that something behind it will have code to execute that. So essentially what it does is it uses regular expressions to match those strings. Given Alice is hungry, there's going to be like either Ruby or Java code that will say, oh, when Alice is hungry, that means I need to instantiate this class, populate these fields, and so on.
Yeah, with the newer versions of Cucumber, you
Sorry,
don't need to.
Just a second. Say that again, Jim.
With the newer versions of Cucumber, at least with Java, you don't need to enter in regular expressions anymore. You can, they've made it quite a bit easier.
Good, good. Glad to hear. Yeah, there was a follow-up.
Is that a test running framework?
Cypress.io, it's somewhat similar to Cucumber, except that, no, I'm not even gonna say it's somewhat similar. They're both for like what some people call end-to-end tests, others call maybe functional tests, but it's to test your application from the outside in, right? Where Cypress.io is just a little bit closer to the application, right?
And Chai?
Chai is the one of the test frameworks that we use when we're writing Cypress.io tests. So that's the assertion library that we use. When we say expect to have this, expect to have that, it comes from Chai. Cool. Excellent. All right.
So actually, one quick thing that I use is I know we sometimes get in the habit of copy paste tests. So before the test method, the given, the when, and the then actually have a logger. So if in case in the logging setup actually prints out the method name. So if on the off chance you accidentally just copy it there, you could say, oh, wait, this is what this behavior is. It helps you find it a lot faster. One of the other things is, Claudio, and I know sometimes I tend to go more of a class-based from a reusability perspective. So you've got the functional bit, but as you drill down to the actual classes, so we can get down to fewer, duplication across. What are your thoughts on that? More of we do the functional, but we also, at the individual class level, though, to get that validated out, because sometimes that method is duplicated across different classes. You don't want to have to or different functions, you don't want to have to recode it 3 times in all the scenarios.
Yes. So that's where I go with this approach of outside in development, where I start from the behavior, I implement the specifications that verify that behavior, I implement the code however I need it to pass those specifications. And when I end up with, say, a class that, okay, right now this class has a bit much and I want to spread that into smaller classes. So yeah, I will pull those bits of code into separate classes, and I will put those classes under test as well, and still following the same principle, where if I had like a bigger class, or not necessarily a bigger class, a point of entry class that serves the business requirements, right? And that business class uses other stuff that I'm like, okay, that behavior does not belong in this class. I want to pull that out. Yeah, I'm going to pull that out, and I'm going to put tests around that class. But again, not around the class itself, the behavior that that class gives to the other. Does that make sense?
Yeah.
Right. So because what I want to reuse is not the class, it's the behavior.
Interesting point. Okay.
Right?
Yeah.
Cool.
Thank you.
You bet.
And don't forget to sign up for the door prize.
That's right.
And also worth mentioning, I dropped it in the chat. Improving is having a virtual conference called the Improving Edge from June 6th through June 10th. It was quite a nice lineup of speakers. The 15 speakers in all, one each morning, one each lunchtime, and one each afternoon. So definitely worth checking out if you enjoy virtual conferences. And one of the speakers will in fact be Claudio Lassala.
I'll be there. So if you haven't had enough of my sexy accents, I'll be doing that thing too.
Very good. And again, you can go to theimprovingedge.com to register. It is a free event, and definitely should be well worth your time.
Sorry, there was a question. Yeah.
Jim, is that going to be Zoom or meeting or Teams?
Zoom.
That's Zoom. Yeah.
Mm-hmm. Yeah. So again, next meeting will be June 29th for the Eastern Drive User Group meeting. Frank Greco will be talking to us about the Vision JSR and how it can be applied to machine learning. So it should be very, very exciting. And I will see you then. Again, if you want to throw up the door prize link real quick, Claudio, and I can go ahead and repost it here as well in the chat for the folks who got here late. Definitely make sure you take a few moments to go ahead and fill out that survey and win something fun. And also worth mentioning that link will expire at midnight tonight, if I remember, Dan. So act quickly.
Yep.
Very good. Okay, cool. Fantastic. Thanks so much. And thank you, everyone who's attended. I'm so glad you joined. And we'll all meet, even though the next meeting will be virtual, since Frank is in New York. We can all plan on meeting in the improving office and have a pizza party and interact with Frank as he presents.
And Claudio, thank you very much. I really appreciate it.
You're
Learned a lot from you over the years.
Yes, thank you so very much, Claudio.
Absolutely. Thanks, guys.
All right. See you next time, everybody. Thanks.
Bye, everybody.
Bye. Bye.
Mhm.